Kirchhoff's current law, or KCL. In 1845, Gustav Kirchhoff announced his laws pertaining to currents within a junction and voltages within a loop. Today we're focusing on KCL, which is the current and how it behaves within a junction. Kirchhoff also studied spectroscopy, which is the behavior of electrons to absorb energy and reach an excited state, and then release that energy in the form of light. They can also absorb energy in the form of light, and specific elements will release specific lights. In fact, using this, in 1860, along with Robert Bunsen, he managed to determine the composition of our very own sun. According to Gustav Kirchhoff and Robert Bunsen, our sun is 75% hydrogen, 24% helium, and about 1% other elements, up to and including iron. You can't talk about a current law without talking about current. Now, current is best described by two different things: Ohm's law and its units, which is charge per unit time. Charge and current have various properties which are important for the establishment of the current law. Q has a minimum value of E-, and Q is inherent to all matter. I has direction, and therefore it is a vector quantity, and Q and thus I carries energy, and therefore cannot be randomly created or destroyed, and must be conserved. The law. So the actual law is I into is equal to I out of when talking about a junction within a circuit. So for example, if you've got a circuit with 2 into and 3 outside paths, then I1 plus I2 needs to equal I3 plus I4 plus I5. An example of this is here, where you've got two unknowns in a circuit, and you know all the other directions and currents. So here, I1 plus 1 is equal to 4, therefore 4 minus 1 is 3, and I1 is equal to 3. Now on the next one, 4 plus 10 is equal to 6 plus I2, therefore I2 must equal 8. And there is KCL.